Right. The first section, rewrite rational functions using long division. Okay, so here we have a rational function. Again, it's a rational function because you have one polynomial over another polynomial written as a fraction, right? So we have p of x over q of x, where p of x equals 3x, and q of x equals x plus 7. So we have the ratio of two polynomials. That's what makes it a rational ratio, which means it's a rational function. Okay, so the first thing they want us to do is they want us to rewrite the rational function using long division. So we're going to do x plus 7 into 3x. We're going to divide x plus 7 into 3x. So I need to cancel out this 3x. So x times 3 is what's going to give me 3x. 3 times 7 is 21. We're going to subtract. So we need to switch the signs. So we're left with the remainder of negative 21. So I have 3 and then minus 21 over x plus 7, right? I got to do 3 and then whatever my remainder is over what I'm dividing by, x plus 7. Okay, so let me rewrite that in here. 3 minus, and then my remainder is 21, negative 21 over x plus 7. Okay. Vertical and horizontal asymptotes. So now, remember, I could have written this the other way too. So I can switch the order. So I can say f of x equals negative 21 over x plus 7 plus 3. Okay, so my horizontal asymptote is going to be y equals 3. Right? So let me put that in for my horizontal asymptote, y equals 3. Perfect. Okay, and then my vertical asymptote is when my denominator is going to be equal to 0. So I'm going to set x plus 7 equal to 0. I subtract 7 on both sides. I get x equals negative 7. So my vertical asymptote is x equals negative 7. That's when the denominator here is equal to 0. So there is a single vertical asymptote, and it's x equals negative 7. Negative 7 is the x value that gives us a 0 in the denominator. Okay, and then the graph. So we should have a, if we were to graph this, you have your x and y axis. Okay, we should have a horizontal asymptote at 3, a vertical asymptote at negative 7, right? And then this is negative, right? Negative. So that means my graph is going to be up here and over here, right? If it's positive, if A is positive, it's going to be in the upper right and the bottom left. If A is negative, you got to flip it, and it's going to be in the upper left and bottom right. So this is if A is positive, and this is if A is negative. Okay, so if we look at our graphs, it looks like it's going to be graph C. Wonderful. Okay, horizontal asymptote, vertical asymptote, negative, so it's upper left, bottom right. All right, let's look at the next one. Okay, same thing, very similar. We're going to start by using long division. So we're going to divide x plus 8 into 2x. So we need to multiply x by 2 to get 2x. So 2 times x is 2x. 2 times 8 is 16. We're subtracting, so we got to switch the signs. And that leaves us with a remainder of negative 16. Okay, so we're going to have 2 and then minus 16 over x plus 8. Remember, we can rewrite this if we want in the reverse order. Negative 16 over x plus 8 plus 2. So doesn't matter which way you do it. Okay. From there, a horizontal asymptote is going to be y equals 2. Right? And your vertical asymptote is going to be x equals -8. So again, we got the 2 because that's our extra piece here, right? If this all goes to 0, we're going to be left at 2. And then when x plus 8 equals 0, when the denominator equals 0, that's your vertical asymptote. So when does x plus 8 equal 0? It equals 0 when x equals -8. So if we were to graph this, right, we would have a horizontal asymptote at 2. And a vertical asymptote at -8, way over here. Okay, and then it is negative. So it's going to be upper left, bottom right. Just like this. Okay, again, if it's positive, it's going to look like this. If it's negative, reversed. Okay. Oh, so we didn't put our stuff in here. So horizontal asymptote is y equals 2. Vertical asymptote is x equals -8, and there's one of them. Okay, so that looks like this one. Perfect. And we're on to number 3. Right. So we're gonna do long division here. So 4x squared plus 3 into 4x squared. Well, it can only go once, right? So 1 times 4x squared. And then 1 times 3. We're subtracting. So that cancels, and that gives us a remainder of 3. So we have 1 minus 3 over 4x squared plus 3. Okay, so we're gonna put in 1 minus, and then 3 over 4x squared plus 3. Okay. Before we do that though, again, you can write it the other way too. So we could write it as -3 over 4x squared plus 3 plus 1. Okay, horizontal asymptote is going to be y equals 1 right here. Okay, where does 4x squared plus 3 equals 0? Well, let's find out. We're going to subtract 3 on both sides. You get 4x squared equals -3. We're going to divide by 4 on both sides. We get x squared equals -3/4. We take the square root of both sides. And we have a problem because this is going to give us an imaginary number, right? This is going to give us plus or minus a square root of 3 over 2i, right? So that I part, right, that imaginary number, that's not on our graph. That's not on our XY plane. So we can't graph that. So there's no vertical asymptote. So this is going to have no vertical asymptote. Okay. All right, so let's check our answer. Wonderful. There's a horizontal asymptote at y equals 1. Okay, and then vertical asymptote. There was no vertical asymptote. There's no value of x. That's going to give us a 0 in the denominator. Okay, and then so if we look at our graphs, we had a horizontal asymptote at +1. Okay, so it's not A, it's not B, it could be C or it could be D, but there's no vertical asymptote. This one has 2 vertical asymptotes, right? Our 2 vertical asymptotes on this graph would be here and here. Since we had no vertical asymptotes, we need to choose option see, it's got an asymptote here, y equals 1. Okay, but no other asymptote. Right, and that makes sense because you can't have a negative value. All right, good. Let's go to the next one. Okay, so we're gonna do the same thing here. 8x. We're gonna divide 4x squared plus 3 into 8x squared. So we're gonna have to multiply by 2. And that's 6. We're gonna have to subtract, so we change the signs. That gives us a remainder of 6. So I'm gonna have 2 minus 6 over 4x squared plus 3. Okay, half of x. Again, I can write it the other way if I would want to. I don't have to. Negative 6 over 4x squared plus 3 plus 2. Okay, so my horizontal asymptote is going to be y equals 2. Vertical asymptote, I need to set the denominator equal to 0. It looks like this one's going to be the exact same thing. So we get 4x squared equals negative 3, right? You subtract 3 on both sides. When you divide by 4, you get x squared equals negative 3 over 4. So when you take the square root of that, we get an imaginary number because of the negative. So there's going to be no vertical asymptote. Okay, so let's fill in our function here. 2 minus 6 over 4x squared plus 3. Right, there's no value of x, or the horizontal is y equals 2. Okay, there's no value of x that gives us a 0 in the denominator, so there's no vertical asymptote. Okay, and so it looks like it's got to be option B. And there you go. And so that's the first part, rewriting rational functions using long division.